Hello everyone. This video is on the Knewton Alta assignment, section 3.1, part 2, called Function Notation. Alright, so in this video I'm going to be going over a preview version of this particular assignment. So please understand that the questions I see in this video may or may not be the same questions that you see when you work on the assignment yourself. Alright, so here's the assignment, but the objectives are the same, sorry. The objectives are the same, so the questions should be similar. Alright, so I'm hoping that watching me go through these here help you in some way when you work on it yourself. Alright, so here's your assignment page. You got the title, you got your mastery bar. The objectives, looks like there are 3 objectives in this assignment. And then underneath the current objective, you have a question related to that objective, and at the bottom of every question, you should be seeing a feedback button to send feedback to Knewton, if you wish. You will not have this instructor cheat button. Right, that's for instructors only. And you will have a more instruction button, which you can click on if you're struggling with a topic. It'll take you to some extra reading, extra videos, maybe, and then give you some questions related to that instruction. And you can work on, and get through the assignment this way as well, going through more instruction every time if you wish. Alright, so this first question's on the objective, evaluate or solve a function from a graph. Alright, so we're given a graph here, and I want to explain something about function notation first. Because the whole part 2, section 3.1, part 2 here is on this function notation. So they're talking about, y equals a function of x, f of x. Alright, this is said as, you say this at f of x is the way it is said. Well, the pieces of this, the letter before the parentheses is the name of the function. So most of the time it'll be a single letter. It can be an entire word if you want it to be, just actually give it a name. Then the parentheses, inside the parentheses is the input variable, or just the input value. All right, and then the whole thing in its entirety, f of x is the output. And that is why they are saying, that's why usually they have it equal to y. Right, because remember, most times the output value was a y value. All right, then on a graph, if you're looking at a graph of some function, it passes the vertical line test and everything. Every single ordered pair, every single point is going to have, some domain value, some x value, so x for the first coordinate, and then some y value. Right. Now remember, the y value, though, is also called, this name of the function at x, f of x. So instead of x comma y, now we're going to see x comma f of x. All right, so input x comma output, f at the value of f at x, or the value of f when the input is x, or what's the output of f, when the input is x. All that stuff means the same thing. All right. Okay, so on this graph they're showing us, I'll draw a very rough sketch here of the graph we're given in this first problem. We're saying what they're telling us, this is the graph of y equals function f of x, right? And I'm seeing some points here of -4, -2. So when x is -4, the output's -2. I'm seeing -2, +2 as the vertex. It looks like a parabola. And also 0, -2, right? And graph looks like this. It's a parabola opening downward like this. Right, this isn't perfect, but like I said, I was making a rough sketch here. And they're asking us to find the value of f at x equals -2. And again, this is the input -2. Right? In the parentheses, that's x equals -2. That's the input. F of -2 equals the output. Right? I need the output over here, or the y coordinate. Right? The y coordinate of that point, the output of the function. So if you go to my graph here, the input's -2. What's the output? Well, here's the ordered pair, -2, comma, and then the output's +2. So this +2, this is the value of f at -2. This is f of -2. It's the output. Right. And looking back on the graph, right? F of -2 means go to x equals -2 and see what the output is. On this graph, it's +2. F of -2 equals +2. I'm just putting what f of -2 equals the output when the input is -2, and that output is +2. Now, after every question, you'll be told if you're right or wrong, and then you'll be given some answer explanations. Please read through these just to make sure you can, hopefully you can read through these and see where you went wrong, or try to learn from your mistakes if you did make any mistakes. All right, next question is still related to the same objective. Now look, it's the same graph. They give us the same graph as earlier. All right, same downward opening parabola. But this time, all right, they say solve for f of x equals 1. And if you have multiple answers, just put commas between them. X equals 2 values, 3 values. So again, I have that drawing here. Now they're saying, where is f of x equal to 1? So you see earlier, they had a number in the parentheses. They told you the x coordinate. Here, it's just f of x. I don't know the x coordinate, but I know the y coordinate is 1. So you go on the y-axis, you go to where y is 1, or where f of x is 1, right? Y is the same as f of x, and find those points. And those points are at x equals -1 and x equals -3. All right, there's -3, 1, there's -3, 1, and there's also the point -1, 1. All right, so -3, 1 is on the graph, -1, 1 is on the graph, meaning that f of -3 is 1, but so is f of -1. F of -1 is 1 as well. All right, so the values of x that make this equation true are -3 and -1. All right, so earlier you were given the input, asked to find the output. Here you're given the output and asked to find the inputs that give you that output, and those would be -3 and -1. And since there are multiple values, multiple answers, multiple solutions, they want us to put commas between them. Right? So -3, comma, -1 also works. So I'm hoping that seems simple enough. All right, so moving on. All right, so now we're to this other objective: solve a function using function notation. All right, so here the input. Now I know it's going to be confusing sometimes, but they're using different letters, I think, just to try to trip you up. But just pay attention. See, we're given a function called g. All right, the name of the function is g, and it's g of y. So here, the input variable is called y, and the output is g of y. And then on the other side, what this is equal to is how you calculate the output. You take 3 times the input squared plus 11 times the input. All right. So let me write this out, and I'll explain all that. I'll write all that on paper. So again, we're given this function called g of y equals, and then if you see this stuff, right, you see g of y, then the other side should have an expression involving the input variable, right, involving y, which it does, right? It's 3 times y squared plus 11 times y. All right, so once again, the variable in the parentheses is the input. The letter or name before it, that's the name of the function. And then the whole thing, called g of y, is the output. And over here is how to calculate the output when you're given the input of y. Right? And if you were to graph this, I know we're not graphing it, but this is the tricky part. Remember, the horizontal axis is the input axis. So that would be called the y-axis this time. And the vertical axis would be called, the g-axis, or the g of y-axis, right, for the outputs. So it'd be a little tricky if you were graphing, but we're not asked to graph here. What we're asked to do is solve g of y equals 4. So notice we're not given an input. We're given the output. We're given an output of 4 and asked to find what inputs would give me an output of 4. Well, over here, what is g of y? How do we calculate this output? That's 3y squared plus 11y. And we're asked, when is that going to be equal to 4? And now I have a nice quadratic equation to solve. So I'm going to solve it by factoring. Now you can solve it by factoring, by completing the square, by using the quadratic formula. But I'm going to take everything to one side. 3y squared plus 11y minus 4 equals 0. And this is actually nice and factorable. And I'll skip the grouping part. I'll leave that to you if you want to do it. But we'd have to have 3y minus 1 times y plus 4. All right, and you can check that. And you got 3y squared plus 12y minus 1y would be plus 11y, and then minus 4. And then by the zero product property, either 3y minus 1 is 0 or y plus 4 is 0. And then solving each of those, you get y equals positive 1/3 or y equals negative 4. And that's what they want, these two values, right? G, and let's check. Let's check over here, see if these values of y actually give me an output of 4, right? We want an output of 4. Well, what's g of, replace y with 1/3, right? And it's very simple, right? Again, over here is how you calculate the output. So if the input's 1/3, here's how you calculate just replace all the y's with 1/3. So it'll be 3 times 1/3 squared plus 11 times 1/3. All right, now 3 times 1/9 would just be 1/3, plus this is 11/3, which put them together, they have a common denominator. Put them together, that's 12/3, which is 4. Great. So an input of 1/3 does give me an output of 4 in this function. Then what about the other one, right? Y equals negative 4. So replace y with negative 4 throughout, right? What's g of negative 4? What's the output when the input is negative 4? That'd be 3 times negative 4 squared plus 11 times negative 4. This is 3 times 16, which is 48, plus, and then 4 times, negative 4 times 11 would be negative 44. 48 minus 44 is 4. Right. Wonderful. So we have good solutions here. An input of 1/3 will give me an output of 4, and an input of negative 4 will also give me an output of 4 in this function. All right, so they want you to enter, they already got the y equals, so you're just entering the numbers. All right, 1/3 was an input that gave me an output of 4, then put a comma, and then negative 4 also worked. Replace y with negative 4 and you'll get a g of negative 4 is also 4. Great. All right, next question. Same objective, basically the same kind of problem. You're given a function here called g. This time the input variable is x, and then over here is how you calculate the output. All right, g of x is 11x squared plus 28x, and we're asked to solve, when is g of x equal to negative 12? Here they're giving you an output, negative 12. We have to find x. We have to find the inputs that give me an output of negative 12. All right, so once again, I'll write this out. So g of x equals 11x squared plus 28x, and we're asked to solve g of x equals negative 12. So notice I don't know x, right? I know the output. I know the y coordinate, or whatever you want to call it, right? The output. So how do you calculate g of x? Well, that's this here, right? G of x is 11 times x squared plus 28x, and we're asking when is this equal to negative 12, and then here we have a nice quadratic equation to solve. So I'm going to add 12, get 11x squared plus 28x, and then plus 12 equals 0. And you can use the quadratic formula. Let's see, is this factorable? Let's see, if I do grouping, 11 times 12 is 132. 132. Hey, you know what? I'm just going to use the quadratic formula. I mean, unless you can think of factors of 132, that would add up to 28. There's 2 and 66. 3 and 40 something, right? I'm gonna 4 and 30 something. 5 doesn't go into it. 6 would. 6 and 22. 6 times 22 would be 132, and 6 plus 22. Okay, so let's do the grouping then. And then I'd pull out a x from this. Alright, sorry if I'm not talking too much here. You should know how to group 2 from that. Okay, so this factors to 11x plus 6 times x plus 2. And then using the zero product property, you can see that x would have to be either negative 6/11ths or negative 2. Negative 6/11ths or negative 2. And then if you wanted to check, now I'll leave this to you though, is g of negative 6/11ths equal to negative 12? And it should be. And how about g of negative 2? That should also be negative 12. Right? It should be. Right? And I'll leave those to you though. Plug in negative 6/11ths for x, plug in negative 2 for x, and you'll see the output is negative 12. Right? If I did everything correctly, and I'm pretty sure I did. Alright, and then again, they have the x equals already. Don't type that in. We're just typing in the numbers, the inputs that would give me an output of negative 12. Negative 6/11ths, comma, and negative 2 as well. Right. Wonderful. Alright, moving on. Alright, so here's a evaluate a function. So this time, instead of giving you the output and asking for what inputs you need, you're given the input and say, what's the output? Now, these are functions, right? So each input should give you one output, right? Remember, that was the definition of a function. All right, so here we're given a function called h, right? H, and the input's called x, right? H, and the output is h of x. And over on the other side of the equal sign is how you calculate the output. It's negative 2x plus 2. And they want you to find what's h of negative 2 right? So again, that's just input is x equals -2. Just replace x with -2. So very simply, it's just -2 times -2 plus 2. Right? Just go through and replace x everywhere with -2, and that's 4 plus 2 is 6. There you go. So input -2, output 6. Right? And if you were graphing, you'd plot the point -2, 6. Right? Input -2, output 6. And that's all they want. Just the 6. Right? What's h of -2 equals 6. Right? Great. All right, next question. That same objective, once again, we're given a function. It's called c of t. I'll write this out. Let's turn this around. So c of t. All right, so the function's called c. The input is t, and the output is c of t. Right, and over here is how you calculate the output. You take the input and square it, subtract twice the input, and then -4, right? T squared minus 2t minus 4. And they want to find what's the value of c at -2. Right, so this means replace t everywhere with -2. So this would be -2 squared minus 2 times -2 minus 4. All right, so this is 4, -4 is 0, this is +4. All right, 8 minus 4 basically, and there's the output. And again, if you were plotting this on the coordinate plane, first value would be -2, second value for the ordered pair would be +4. You find that on plot a point. Right. But all they want is the output, right? When the input's -2, here the output would be +4. Okay, simple enough, I feel. All right, this again. Alright, so once again I'll write this out. We got a function called h. Right, h of t equals the opposite of t squared minus 2 times t minus 4. And they want what's the value of h when t, right, t is replaced by the number 2. So just go through the rule here, how you calculate the output and replace all the inputs with 2. So this is the opposite of 2 squared minus 2 times 2 minus 4. So this is -4, and then -4 again, then -4 again. This is -12. Right. Okay, so that's all they want. Right? The output when the input is 2. That'd be a -12. Great. Alright, I guess we're just doing 4 in a row of these. So again, they give me the name, some function notation, some rule for a function, how you calculate the output when the input is x. And you're plugging in -1 for x. I'm just going to do this one out loud. This would be -4 plus -4 would be -8 plus 3 is -5. The output would be -5 if x was replaced with -1. Alright. Wonderful. Okay. Alright, so that's it for that objective where you're given an input and find an output. So now let's go back to the one where you're given an output and you have to find, oh no, it's the graphs, sorry. Evaluate or solve a function from a graph. So again, here's a graph of another parabola. It's not always going to be a parabola, but it's a graph of some function, right? Passes the vertical line test. And what's f of -2? So here we have the input. They want the output, right? The number in parentheses is the input. So I go to -2 on the horizontal axis and then go to the point on the graph, and that has a y value of 4. So f of -2 is 4. Input -2, output 4. And then continuing on, they'll just take me to the same graph, right? Same graph. But this time, see, it's f of x equals 2. So we don't know x. We don't know the inputs, but we know the output. The output is 2. So I go to the vertical axis, right? The output axis. Go to +2 on that. go to the points on the graph that are lined up with that. That's this point and this point where x is -1 and where x is -4, right? -1 has an output of 2 and -4 also has an output of 2. So the answers are, x equals -1, comma, and also -4, right? They ask you to separate the possible answers by commas. And pretty easy, I feel, right, when looking at a graph especially. Alright, then the last question should be where you're given an output and asked to find the inputs, like earlier. So yeah, so here's a function called h, right, and the input is the variable a, and the output is called h of a, and then over here is how you calculate the output, 9a squared plus 46a. We're asked to find when is h of a equal to -5, right? They gave me an output. They want to know what inputs take you to an output of -5, right? So I'll write this one out. All right, so h of a equals 9a squared plus 46a. And we're asked to solve, when is h of a equal to -5? So when is this output here, the way you calculate the output, 9a squared plus 46a, when is that going to be equal to -5? And then we have another quadratic equation to solve, and it looks like another nice factorable one, right? If I take everything to one side, and 9 times 5 is 45. 45 and 1 add up to 46. So this will actually factor pretty nicely. I'll just jump to the factors. You can do the grouping yourself if you wish. So we'll have 9a plus 1 times a plus 5. Right? And that'll be 9a squared plus 45a plus 1a and then plus 5. Cool. So a has to be either, -1/9. That'll make that factor 0, and then -5 for the other one. There's the possible solutions. And if you wanted to check, plug them in. Is h of -1/9 equal to -5? And it should be. Right, just go through, replace a with -1/9. Should end up with -5 at the end. Same thing for -5. Replace the a's with -5 and see if the output is also -5, and that should also be the case. All right, but they want us to put what I circled here, -1. The inputs that give me an output of -5. So inputs a equals -1/9, comma, -5. Right. Great. All right, I should have just one more of these. Yeah, so here's h of q, some fourth root function. Remember, that's the fourth root, not square root. All right. Solve for, h of q equals 1. So what values of q will give me an output of 1? All right. So again, I'll write this out. So once again, we have h of q equals the fourth root of 4q plus 11. And we're asked to solve this equation. When is h of q equal to 1? What inputs q give me an output of 1? Well, h of q, the way you calculate h of q is this, right? So that's the fourth root of 4q plus 11. When is this equal to 1? Raise both sides to the fourth power, so that we have 4q plus 11 equals, now 1 to the fourth power is just 1 again, and then subtract 11 here. You got 4q equals 1 minus 11 is -10, and then dividing by 4, q equals -10 fourths, which reduces to -5 halves, or -2.5, and that seems to be the only answer. And then if you want to check, is h of -5 halves equal to 1? Right, it should be. Now I can do this pretty quickly. 4 times negative 5 halves would be negative 10. Negative 10 plus 11 would be 1. The fourth root of 1 is indeed 1. Right? Remember, this symbol means the non-negative fourth root. Right? So don't say it's negative 1. I mean, I know negative 1 to the fourth power is 1, but the symbol means, the principal fourth root, the non-negative fourth root. Alright, so I'm entering this, right? The input that gives me an output of 1 is an input of negative 5 halves. Or negative 2.5. I think it'll take the decimal as well, as long as it's equal to the correct answer and simplified. Great, and once again, please read through your answer explanations. And that should be it for this preview version of this assignment. As I said at the top of the video, right, just please understand that the questions I saw here are not going to be the same exact questions you see when you work on the assignment yourself, but the objectives are the same. And so the questions should be similar, and the way you go about them would be similar to the way I did them. So I'm hoping that watching me go through these examples here help you in some way when you're asked to do it on your own. And thank you very much for watching.